Hello and welcome to this screencast on matrix multiplication. So today, if I have a look at, I'm going to draw a 2 by 2 element matrix here. So this is a matrix with 2 rows and 2 columns, and I want to multiply this by another 2 by 2 matrix. Okay, so this is matrix multiplication. We want to be able to multiply this matrix on the left by this matrix on the right. Now there's a couple of things you've got to remember when dealing with matrix multiplication, and that is the number of columns in the left matrix has got to equal the number of rows in the right matrix. Okay, so in order to check this, what I tend to do is I just write the dimensions of my matrices underneath. Okay, and the little trick is, remember the dimensions are number of rows by number of columns. So this second number here means number of columns, the first number means the number of rows. So if these two middle numbers here are the same, I can multiply these two matrices together. If they're not the same, matrix multiplication is undefined. Furthermore, the resulting matrix, or the product of these two matrices, is going to be a 2 by 2 matrix. So that's these outside numbers. Okay, so that's the first thing to remember. The second thing to remember is when we multiply two matrices together, on the left matrix we always go horizontally, we'll always go across the rows. And on the right matrix we always go down columns. Okay, so I'm going to end up with a 2 by 2 matrix. So the element in the first row, first column, what I do is I'm going to proceed. I'll just choose a different colour there. I think I'll go for magenta. Okay, so what I do is I'm only interested in the first row, A and B, and the first column, E and G. Okay, so across the left matrix, down the right. What I do now is I'm going to multiply A by E, and I'm going to add it to B times G. So I end up with A times E add B times G. And that's the element which is in the first row, first column of the matrix, which is the product of these two matrices. Okay, well if we move across to the second element in this matrix here, this is first row, second column. So I'm still on A and B here, because that's the first row. Now I'm going to move across to F and H. Okay, so I'm going to move across to the second column. And I do the same thing. I multiply A by F, and I multiply B by H. So I end up with A times F plus B times H. Okay, now I've done the top row. I've done the first row. So now I'm going to move on to the second row on the left matrix. Okay, so now I'm interested in the second row on the left matrix. So I'll go to C and D, and now I'm back to E and G again. So I'm back to the first column. So second row, first column. So I have C times E plus D times G. Okay, and finally, I'm still on the second row of the left matrix, but now I'm on the second column of the right matrix. Okay, so I'm back to F and H here. So I'm just going to use orange for this. So now I have C times F plus D times H. And that completes the matrix multiplication of a 2 by 2 matrix. So that may look quite confusing with the letters, so I'm just going to go for an example involving numbers. I'm going to make up a matrix 1, 2, 3, 4, 5, 6, 7, 8, might as well. Okay, so I'm going to multiply these two matrices together. So the first thing I do is I do my check of whether the number of columns in the first matrix is equal to the number of rows in the second. This is quite a trivial example, as you can see. It's 2 by 2, so you could always multiply two square matrices together. Okay, so first row, first column. So we go along the first row of the left matrix and down the first column on the right matrix. So I have 1 times 5. Oops, let's start that again. I have 1 times 5. That's added to 2 times 7. Okay, so first row, first column's done. First row, second column. In this case, I'm still on the first row. I'm still on 1 and 2, but now I move to 6 and 8. So I have 1 times 6 and plus 2 times 8. Okay, so top row's done. Now move to the second row, so I'm on 3 and 4 this time, and back to the first column of 5 and 7. So 3 times 5 plus 4 times 7. And finally, second row, second column. So second row is 3 and 4, second column 6 and 8. So 3 times 6 plus 4 times 8. Okay, now we have to just do the arithmetic. So 1 times 5 is 5, 2 times 7 is 14, 1 times 6 is 6, 2 times 8 is 16, 3 times 5 is 15, plus 4 times 7 is 28, 3 times 6 is 18, plus 4 times 8 is 32. Okay, so just evaluate those sums. We have 19, 22, what's that, 43, and that's 50. Okay. And that's the product of those two matrices. I want to show you two further examples, just to show you examples of using matrices of different dimensions. And in this example, I'm going to multiply a 2 by 3, just making the numbers up at the top of my head. Okay, so that's 2 rows, 3 columns by a 3 by 3. Oh no, a 3 by 2 actually. I don't want to make it too difficult for myself. Put in a couple of different numbers. Okay, so you see immediately these two, and this is example 2, if I forgot to. These two are of different size, so different size matrices. But if we do our check, I'm going to have, this is a 2 by 3, and this is a 3 by 2. As we can see, the middle numbers are the same, so we can do the matrix multiplication. And the product of these two matrices is going to be a 2 by 2 matrix. So the product isn't always the same dimension as the matrices which you're multiplying. Okay, so it's going to be a 2 by 2. So first row, first column, I go along the first row of the left matrix and the first column of the right. Okay, so I have 1 times 1, which is 1, plus 0 times minus 1, which is 0, plus 3 times 4, which is 12. Okay, so that's first row, first column. Now it goes first row, second column. So I have 1 times 2, I have 0 times 3, and plus 3 times 5. Okay, so that completes the first row, down to the second row. So I'm now on the second row of the left matrix, and back to the first column on the right. So I have 4 times 1, which is 4, plus 5 times minus 1, which is minus 5, plus 2 times 4, which is 8. Okay, and finally, second row, second column, second row, and then we move to the second column on the right matrix. We have 4 times 2, which is 8, 5 times 3, which is 15, plus 2 times 5, which is 10. Okay, so now all I have to do is just evaluate the sums. So 1 plus 12 is 13, 2 plus 15 is 17, 4 minus 5 is minus 1, plus 8 would be 7, and 8 plus 15 plus 10 is 33. Okay, so you can see two matrices, not necessarily the same dimensions, but they can still be multiplied because the number of columns in the first matrix has got to be equal to the number of rows in the second. So what happens if that wasn't the case? Just do a deliberate example where we can't do it. So I'm going to stick with my left-hand matrix, which is a 2 by 3, just making the numbers up. And this time I'm going to multiply it by, or try and multiply it by a 2 by 2. Okay, so I'm not going to do the check. You can see the number of columns in this matrix is 3, the number of rows is 2, so therefore, okay, I'm going to just go ahead. Let's pretend I haven't done the check. So if I go across the first row, I'll have 1, 0, and 4. Down the first column, I've got 1 and 2. So it'll be 1 times 2, 1 plus 0 times 2, and that's plus 4 times, oops. Okay, can you see there's no number for 4 to be multiplied with, so you can see, hang on, we can't do this, it's undefined. Okay, so we'll say that this matrix multiplication can't be done, and it's undefined. Okay, so that's matrix multiplication. Hopefully you're happy now, and you can go on and multiply to your heart's content.